Hi everyone, ideaForge and Caresoft Technology would like to welcome you to our webinar, UAV Mapping at Scale with ideaForge, from mountain terrain LiDAR data acquisition to automated cloud processing. Okay, and at this time, I'd like to introduce our speakers for today, Pradeep Pandurangi and Will Dillingham. Pradeep brings extensive experience in designing UAV workflows and geospatial data solutions tailored for enterprise GIS and mapping applications. He has led numerous successful large-scale drone deployment projects across infrastructure, utilities, and public sector clients, helping them realize operational efficiencies and data-driven decision-making through cutting-edge drone technologies. We're also joined by Will. Will Dillingham is Senior Manager of Product Marketing at Inertial Labs, specializing in LiDAR and inertial navigation solutions for drone and mobile mapping applications. With a background spanning application engineering and product management on platforms like the Recipe LiDAR payload, he focuses on turning complex positioning and remote sensing technology into practical, field-ready solutions for surveyors and geospatial professionals. And with that, I'd like to pass things over to Pradeep to kick things off. Pradeep, the floor is all yours.
Thank you so much. And good afternoon, everybody. All right. Thank you. Thank you all for joining. As Husna said, my name is Pradeep Pandurangi, and I represent ideaForge Technologies. So today, I will be taking up part one for about 35 to 40 minutes, introducing you all to ideaForge, talking about the need for high resolution mapping in mountainous and hilly terrain. We'll talk about the entire technology stack that ideaForge brings to table and the important components of it. And then finally, we'll look at deep dive into a use case where we will show you how we deployed our entire technology stack in a mountainous area for mapping. Part two will be taken up by Will, who will talk in more detail about the LiDAR payload itself. And then we have about 10 minutes for Q&A. So quickly about ideaForge, for those who are hearing this name for the first time, we are ranked number 3 globally by Drone Industry Insights for dual use drone category. And that comes from a lot of history. The company is actually 18 years old in the UAV business. And that's how long legacy we carry. Today, we are a publicly listed company in India, and with more than 500 employees, as you see, we completed more than 750,000 missions. So every 3 minutes, ideaForge drone takes off. That's the level of deployment that we have. And we are very technology focused. We have 96 patents, both granted and pending. And we work with global companies. So Qualcomm is one of our strategic investors. And we work with a lot of American companies as well. FLIR is very famous for its thermal camera technology, and Inertial Labs will present in much more detail in the following next part about the LiDAR payloads from them. So this is about our company in general. If you look at the UAV that we produce, earlier we have been producing what is called SUS, so small class of US, right from a 2 kg platform going up to 6 to 10 kg. So what you see here, Q6 V3, Switch V2, these are all in the class. The quadcopters are about 6 to 7 kgs, and the Switch going up to 10 kilos. The Switch actually goes up to flight time of almost 2.5 hours. The Zolt and the Yeti are two new classes that we are currently developing. Zolt is a 50 kg MTOW platform for ISR and higher payload capacity. And Yeti is actually a logistics drone. But today the focus is going to be on the Q6 V3 class of platforms. And I will talk more about them as well. This is to give a broad overview of our portfolio. Talking about the geospatial products that we have built over the years. Many of you might not know, but in India, actually, there was a huge scheme by the government to promote drone mapping specifically in 2020, where more than 600,000 villages were mapped exclusively using drones. And almost 70% of the drones used there were ideaForge drones. So we have hundreds of thousands of square kilometers being mapped with our drones to survey grade accuracy. So all of our drones are actually PPK enabled. And now, with the success of that program, the Indian government has launched a 3D mapping scheme called Project Naksha, where they plan to do 3D mapping of the cities and towns, more than 4,000 cities and towns all across India. Below, you see the various products that we have launched. And today we are going to talk about Q6V3 and Q6V2 Geo. Over the time that we have developed these products, we have also understood the importance not just of efficiently and effectively capturing the data, but also because UAV data is heavy and needs a lot of processing, we have worked out solutions which actually solve the problems of data logistics, processing, and sharing as well. And the answer to all of this was actually Flight Cloud. And I'll be showing a little glimpse of that as well, how it can make the entire process very seamless. So what makes ideaForge unique and why is a company from India being talked about and being ranked so highly? The reason is that given the diverse geography of India, we have been, in a way, forced to create our USP, making reliable and rugged drones that can work in any kind of terrain and extremely harsh environments. So, as you know, the northern part of India, we have the Himalayas, some of the highest mountains in the world. So, we build almost all of our drones to work at almost, you see, 20,000 feet. AMSL is the highest takeoff that we design our drones for. At the same time, on the western part of India, you have the Thar Desert. So we design also for very high temperatures. And that's actually a link that I want to talk about today. Because if you look at the terrain map of US, that's something that is very common between the countries, where again, you see a vast terrain with a lot of diversity in the terrains that are there and environments that are there. So here as well, you require a product that is rugged and reliable across the terrains. So let's come to the next part and talk about the need for UAV mapping in tough terrain and harsh environments. I was actually looking at the interesting places in US. You have the Great Smoky Mountains, which one of the largest biodiverse places in US. With a lot of vegetation, it would be so nice to do the mapping, and I'm sure there are projects happening there to do contour mapping of the hills over there. Similarly, the mining happening in Mountain Pass. Again, quite a mountainous and hilly area. And it's becoming more and more important to access this area, build infrastructures in these areas in order to cost effectively mine the resources available there. So when you have a detailed remote sensing possibility to be done at scale, what that allows it is that you can do infrastructure projects better, you can build more efficient roads, you can do earthwork estimations much better. A lot of hydrological projects like dams and rivers, those can be mapped more efficiently. Of course, the LiDAR mapping can be useful for forest conservation and inspection of utilities as well. So this is exactly what we have been doing. Like I mentioned, I've been personally going to Leh and Ladakh, which is in the northern part of India. Like I mentioned, very high altitude. What you're seeing on the screen here is 4,500 meters AMSL. It's a cold desert in India. And last couple of years, we've been really testing our products over here and pushing them to the limit. And we'll be bringing some of those learnings and sharing with you all today. So let's talk about the technology stack itself. So at ideaForge, we look at the complete stack of products. The reason for this is everything needs to work seamlessly when you want to do large projects, and the data transfer, data formats between each of them have to work smoothly. Otherwise, the operators spend time trying to figure it out by themselves, and some amount of data or metadata can get lost and can result in not the most optimum output. So we just don't make the UAVs. We also make the GCS and control software. We tightly integrate the payload, and we also have Flyght Cloud software, like I mentioned, for data processing and sharing. And you will see the consequence of having a vertically integrated stack as we talk about the features required to operate in such a harsh and difficult environment. Let's start with talking about the requirements. Let me just have a sip of water. When we look at starting a UAV mapping project, we obviously start with looking at what are the regulatory compliances, what are the features that I want to extract finally for my GIS. Obviously the altitude and environment, the area to be covered, and how I'm going to share the output finally. Do I need PPK or RTK accuracy? All of these are relevant questions. Data security is a very important question nowadays. And when the answers to these are clear, it can help us to choose the right technology. So since we also make hybrid VTOLs and quadcopters or multicopters, as you may call them, and this is our learning, is that when you want to do larger area coverage in more or less plain terrain, mapping using a hybrid VTOLs can make a lot of sense. But when it comes to hilly and mountainous terrains, quadcopters and especially with LiDAR are really the data output quality is much better in our experience. And this is because you can have generally more tolerant to different weight of payloads. You can do much better terrain follow because you don't have to maintain a fixed speed like you need to do in a fixed wing say a fixed wing VTOL. For a quadcopter, you can fly much slower, and we will see a result of that is the point density of LiDAR can be much higher. And hence quadcopter is the right platform for the kind of terrain that I'm about to show you. So let me introduce the Q6V3 UAV, which is the flagship quadcopter that we have launched in US. It's an NDA compliant system with less than 8 kgs maximum takeoff weight. It is completely backpackable and modular, so one person can carry it on his back. It has a 75-minute endurance with the EO/IR payload. With a LiDAR, the endurance will be somewhere between 45 to 50 minutes. It has a lot of features. I won't go through each one of them, but it's a completely autonomous drone. We have our own flight planning software as well for the mission planning like you do. And a variety of payloads. Today we will talk about the LiDAR mapping payload specifically. So before we go to LiDAR, I want to spend a couple of minutes also on the question around what is the right payload for me? Oblique camera and photogrammetry, is that the best solution, or LiDAR the best solution? So the answer really depends again on what kind of features you want to extract and the terrain that you're operating in. If there's a lot of vegetation, if the altitude variation is a lot, if you want to capture power lines very precisely, then LiDAR is a better solution, right? But you have to be aware that in case of water or moist surfaces, the performance of LiDAR might degrade a bit. But again, this is something that will come from experience. And once you know your requirements very well, you know which season you're mapping in, this can help you make the right choice. But one thing is clear, that if you want to make very good contours and elevations in highly vegetated areas like you find in the mountains, then LiDAR is a better solution. Let's look at an example here. For those who are golf enthusiasts, might appreciate this. This is my local golf course. Don't ask me my handicap. But here you see on the left side a 3D model made from oblique. And on the right side, you have the output from the LiDAR. So actually this building here is out of bounds. It's not part of the course. So they have put in a net here. It's not part of the property. And when you take an iron from here onto the green that you see on the top left, There is actually a net that you can see in the LiDAR, which is protecting the ball for wayward shot that should not go towards this property. My ball has never gone into that net, but for some people, it does go there. But on the oblique, you see that it's completely missed. And that's again, when it's a thin net which is not captured or rather eliminated, as it's part of the photogrammetry process. So you get better texture here, but when you want to capture thin features, you want to capture vegetation precisely. Example of why LiDAR is important. Here is a cross section, another part of the course. You see the vegetation, the ground under the vegetation very clearly visible with the LiDAR output at the bottom, whereas the oblique misses the ground under the vegetation. This is the same way you see the cross section being taken. So all in all, this is a bit about LiDAR versus photogrammetry. Coming to the type of payloads that we offer on Q6, you see here the three types of payload. Show them LAV and LXT, which are the ones we have launched currently. Each of them has their own advantages and strengths. The LAV has a 24 MP camera along with the LiDAR. So in the same flight, you could do both photogrammetry and LiDAR mapping. Whereas the LXT has the data is more crisp and precise, and it also has a SLAM mode. So we actually give an accessory where you can put it on your a backpack accessory or a handheld accessory where you could do indoor mapping with it as well. But the most interesting one, the Echo one, something that we'll talk about in more detail, is the one that they're going to launch very soon. And I'm very excited about a fully NDA compliant solution with 8 returns. And that some of the data that you will see will really blow you away. So coming back, when you have to do contour mapping, contours for hilly and vegetated area, the LiDAR plus quadcopter definitely wins, no matter what other UAV technology you compare it with. And that's something that we have seen actually in the projects that we do very regularly in the Himalayas. Another output, just to show you a comparison of the point density with the LAV payload. This is just the point density from a fixed wing VTOL competitor. And you see here LAV, even at 10 meters per second, it has higher point density at various AGL, above ground level. And you can fly much slower if you want higher point density, and you can really improve the penetration that you get. Another feature which is very important in this kind of hilly terrain is airborne data relay. So there might be some cases in which you need to actually follow the terrain very closely on the other side of the hill, but you don't have line of sight, or you don't have a very good a takeoff spot on the other side, or maybe it's just inaccessible. So what do you do? So our Q6V3 actually supports ADR mode, where you need two UAVs. One will act as a data relay or radio for the next UAV, which can then follow the terrain more closely. So in this case, you maintain the communication with the final UAV, and you're in total control while still doing very, very inaccessible areas. Similarly, negative altitude flying, so you can take off from a higher point. This shows in a mine, in a deep mine, the UAV can actually take off from a higher location and go fly safely in negative altitudes and then come back. This again saves a lot of time, where you don't have to travel to the bottom of the pit, or in again hilly areas, the bottom may simply be inaccessible. These are very important features, and I'll show examples of how we actually use them as well. And finally, I want to talk about the software. So all of this data collection, essentially, we don't want our operators to spend time with 3, 4 different softwares. We have one software called Map Assist, and we have a version of the similar one for LiDAR as well. Once the UAV lands, it's a one-click solution that automatically downloads the base station data. You just have to click a geotag. It geotags your all your data, whether it's photogrammetry or LiDAR. And if you have network on your GCS or ground control station, it uploads it to Flyght Cloud. On Flyght Cloud, essentially, you can then queue whatever post processing that you want to do. So whether it's tree counting, encroachment, vegetation counting, all of that is automated, and it is essentially something where a place where you can store your data, you can easily share with your customers who may not have GIS viewers available, and then you can queue a lot of workflows that you do very often. It is essentially not just automating the flying part, but also the data analysis time and the turnaround time for delivering the data to customers. We feel is something that it needs a lot of work. Today, the industry is people. There are some people who make custom scripts and try and automate some of that, but we want to again do it at scale, bring it to more people, and hence that's the reason for launching Flight Cloud. You can actually sign up, and there are free credits. You can look at the demo data and try it yourself as well. I will now move to the most interesting part where I want to show a use case of a project that we did in the Himalayas, and where all of this technology that I showed you was actually put to use. And you will see some of the outputs that we generated. So this project is the total area that we had to cover was 500 square kilometers. The elevation was from 600 up to 2,600 meters of AMSL. Extremely narrow valleys, dense forests is something that we have to cover. Let me show some more outputs over here. And the government is essentially planning a lot of infrastructure, road and dams in this region, and they need very precise contours for this. They tried using helicopters and aircraft, but the valley was too narrow for an aircraft, and there were too many power lines going across the valley, which made it very dangerous to fly helicopters inside these valleys. Hence, they chose essentially ideaForge drones, because a lot of people tried and failed to capture the data in this terrain. A quick 2-minute video to explain the whole story, then I'll get into the details.
In the remote Himalayas, precision mapping is unlocking critical insights to protect lives and plan smarter infrastructure. By mapping glaciers in high resolution, scientists can monitor snowpack stability, predict avalanche risks, and take preventive measures before disaster strikes. In mountainous river basins of Terry, LiDAR surveys guide tributary rejuvenation, conserve biodiversity, and protect fragile ecosystems from erosion and habitat loss. Detailed elevation models reveal flow paths invisible to satellites, enabling precise watershed management. In Ladakh's cold desert, high-altitude mapping supports track cutting, optimal route planning, and strategic mobility in the harshest environments. Every contour of mountain passes and valleys is captured for roads, power lines, and critical infrastructure. But these missions face relentless challenges. From extreme altitudes and dense vegetation to regions beyond the reach of satellite data. Enter the Q6V2 Geo, built to map where others can't. With terrain follow precision, it maintains optimal LiDAR scanning distance over steep gradients, ensuring every data point is accurate. Flying slower increases LiDAR point density, delivering engineering-grade terrain models. Compact and agile, it launches and lands where larger UAVs cannot. Portable and mission-ready, it reaches sites where traditional mapping tools never go. Advanced data relay ensures uninterrupted mapping in GPS-challenged zones. With long flight endurance, it maximizes coverage in short weather windows. By combining slower, terrain-aware flight with LiDAR precision, it delivers high-quality terrain models for the most demanding projects. From glacier studies to infrastructure planning, dam construction to forest conservation, it redefines aerial mapping possibilities. Q6V2 Geo, map where others can't.
Great. So now let me show some actual KMLs that are plotted. These are actual KMLs that were flown to cover the valley, and you can see how they have covered essentially from this one point, all of these areas being covered. You see this. You see the altitude variation was almost 1,000 meters in certain places. Yeah. Just a view of the same. A little bit more raw footage after the sleek marketing video. So this kind of builds the appreciation of where they were taking off from. The roads, they were very narrow, and in some cases they had to take off from even vegetated areas. You see it from the almost a cliff over here. So these are all the challenges that I already mentioned in a mountainous area, right from inaccessible areas to roads that were blocked, the rain as well. So you also need IP minimum IP54 compliance for, and we have that for both the UAV and the payload. So you may be flying and it might start raining or drizzling. So you have to have the minimum IP rating so that at least when it returns to home, the payload or UAV doesn't get damaged. Power lines in the valley, you have to be very careful. How do you manage that? And obviously, when you want to do precise terrain follow, a lot of times the digital elevation models that are available are not precise. So how do you handle all of this? I already mentioned some of the features that we used was the airborne data relay, which was essential in this case. Without this, a lot of those valleys simply could not be mapped because they were so inaccessible. There were no roads to get there. Some of the slopes were actually almost 65 degrees or more. So you have to make your flight plan or adapt your flight plan to capture such high relief terrain. And obviously the power line. So the way we solved it was by actually doing RGB flight from higher altitude, then creating a digital elevation model from that, and using that. And our flight planning software actually allows that to import a custom elevation model that you create, and it does a terrain following using that custom elevation model. So that's how we were able to kind of do the terrain following much better. The other piece that this image shows here is the flight planning. Now, typically on a flat surface with LiDAR, you don't need a lot of side overlap. Even 30% side overlap is sufficient if you don't plan to do photogrammetry, just a pure LiDAR data collection. But in this case, since the slope gradients is so steep, like we mentioned, essentially your effective FOV, because the laser has a certain range, is much less. So you have to increase the side overlap. A 30% overlap will leave a lot of gap between the tracks because there's only a certain distance. In this case, 100-meter AGL is the one that is optimal for LAV, the sensor used in this project. So we had to actually increase the overlap to 70% side overlap so that the laser range is sufficient in those terrain. And we optimize that because there is always a trade-off between the area coverage and productivity. As you increase the side overlap, your area coverage per flight decreases. So we actually made a slope map of the entire region with the RGB mapping that we did. And then we did the overlap as per the slope in that region. And that's how we were able to optimize this, ensuring the data coverage and there are no gaps, at the same time increasing productivity and keeping the area coverage per day on the higher side. For the power lines, we used a lot of open source data that is available and sourced the vector data of power lines going through the valley, and we use that as well in our software to optimize the flight plan. This just talks about the various elevation models that we tried to use. The open source one obviously was 40 meters off. A Cartosat is an Indian satellite which was accessible to us. That itself was also 25 meters off. It doesn't capture the trees, and it's just not sufficient to if your elevation from the ground is off by 20 meters, basically you will not get the ground points in such a, especially when you want to penetrate vegetation. Yeah, this is a slope model that we made and made the flight plans accordingly. So these are some operational learnings, and we had a lot of them that we did. And here are some glimpses from the output itself. Again, it just kind of drove home the point, the importance of LiDAR doing the job well in such a mountainous and vegetated terrain. On the right, you see the classified point cloud. With the red, you see the buildings and the vegetation in green. On the bottom left, you see the colorized point cloud as well. Another good part about LiDAR was that it works independent of the lighting conditions. So if the colorized point cloud is not of very much importance, in low light as well, you can fly and capture data, which is important because here again, in northern part of India, the daylight hours were not so much. And there were frequent, like we said, rains coming in and out. So again, having the ability to map without worrying about the lighting conditions, which is very important for photogrammetry, that actually helped increase the number of hours that we could work. And obviously the vertical accuracy, it's you can be sure that it's better in LiDAR. Here, top right, you can see a bridge classified over here over a river. And the other part also is, for example, in the desert region of Ladakh, there are very less features, and photogrammetry depends on identifying those features to do the aero triangulation and build a orthomosaic. So when if you are going through very thick vegetation or a desert or a glacier snow kind of area where there are not too many features, LiDAR can be better over there as well. And when you come to precision of volumetrics and slopes, again, the data collected from LiDAR is much more trustworthy in that case as well. And finally, we uploaded all this data on Flyght Cloud. I would love to show a detailed walkthrough of that as well, but maybe that calls for a separate webinar. All the automation that I spoke about with one-click geotagging and data sharing is available on Flyght Cloud. I would encourage you to use this link to sign up and experience the platform yourself. There are a lot of different kinds of demo data sets available, including LiDAR data sets. And it's an easy way to upload and share drone data, any kind of drone data, whether it's photogrammetry, LiDAR, or even video. And it's completely data drone agnostic. So any kind of data can be uploaded to this platform and shared and processed. Finally, you see, this is just one block out of the 50 square kilometers that we created. The DEM and the orthomosaic were the main outputs and classified point cloud that we delivered to the end customer. And yeah, with that, I would like to thank you for your time and listening in. Please write in some questions that we will answer towards the end, and I would now like to hand over to Will, who can talk a lot more and in much more detail about LiDAR payload that we have been talking about.
Thank you.
So over
Thank
to
you,
you,
Pradeep. Thank you. And for the record, I'd love to hear what your handicap is.
Will.
I think that was a great example there. I'm gonna go ahead and share my screen. All right. I'm just confirming you guys can see everything.
Yes, we can see.
Awesome. Fantastic. Well, thank you guys for joining. Thank you so much. I'm just going to be talking a little bit more specifically in detail about some of the LiDAR products and specifically the Echo One payload that Pradeep has made mention of. One of the reasons we've really enjoyed our partnership with ideaForge is, as you've seen, they have a very complete end-to-end solution. Data collection, the drone looks great too, very functional, and all the way to data processing and sharing. So I hope this has been as informative for you guys as it has been for me as well. All right, so I'll just go ahead and jump into it. Some quick introduction of Inertial Labs. We were acquired about a year ago now by a company named Viavi Solutions, but Inertial Labs has 25 years plus at this point of expertise and experience in position navigation and timing technologies, primarily around inertials, IMUs, and navigation Kalman filtering, so navigation algorithms, if you will. This has led us in a bunch of different avenues over the years. Here's a quick little slide that kind of shows you the evolution of products. Started doing more government contracting in the early 2000s, MEMS technologies, accelerometers, gyroscopes are used in all different kinds of components, including our cell phones, drones, and also plenty of other things, autonomous platforms, weapon aiming systems. So we've been able to take our technology and evolve it to fit a very large plethora of various applications. And right around 2019 is when we started getting into the remote sensing space more directly. We had been integrating our inertial navigation systems and IMUs into other LiDAR payload products for a few years beforehand. So we had a good understanding of time stamping and critical alignment with the LiDAR packets coming in, the Velodyne pucks, as some of you are, I'm sure, aware of. And what we knew was there was an emerging market that was significantly more volume driven and cost sensitive that we wanted to begin to support. So we've been now shipping our products internationally and have been known, especially in the United States, as the dominating entity for remote sensing payload instruments. We've offered these products with multiple different configurations that span a vast audience of use cases, from indoor mapping, mobile, aerial, in all kinds of different environments. One of the things we do pride ourselves on for the inertial measurement units and our navigation systems and the payloads is we've spent an extensive amount of time working with military customers and all of very rigorous requirements for hardened technology to be used in all kinds of different facets. So vibrations, shock, EMC, EMI. We've thoroughly tested and qualified our products. So moving into the survey world, where people tend to not shoot these things out of a cannon, made for a nice transition. But we've also done a decent amount of algorithm development outside of just our traditional loosely coupled position estimates to be able to support more GPS denied SLAM workflows as well with many of our products. But today I'm going to talk more specifically about what we have partnered with ideaForge on, and try to change slides. There we go. To discuss why the complete solution as a whole, using their Q6 drone software and our payload, really makes sense. The first one is really just performance at large, technically capable to solve the problem at hand, to deliver results that are accurate and precise. And the second one is market adaptation. The last couple of years have really been, I think difficult, but necessary to adapt to handle a lot of the geopolitical climates, especially if you're in any type of manufacturing. It was COVID where everybody was running out of parts, and then it was geopolitical where now you can't use those parts even if you could get those parts. So Inertial Labs and ideaForge have both spent a lot of time making sure that the products that we're offering are sensitive, not only in performance but also in market adaptation. And then the last thing is built for the environment that it's going to be used in. As I said, Inertial Labs has an extensive amount of experience working with military customers, where we are genuinely pushing the edges of what can be done to technology. So we've taken that know-how and that information into our LiDAR solutions as well, and made sure that regardless of the environment, the terrain, the altitude, the temperature, that we have products that can serve in that area. I'm going to touch a little bit more specifically on each one. Performance. For those who aren't aware, there's a number of different types of inertials that can be used in these various types of payload solutions. The most common one in the recent years has been MEMS. So these are kind of chip-based components that get assembled and end up being calibrated, can be over some type of operational temperature range, and then algorithms are used to apply various coefficients, so that regardless of the environment, the inertial system is outputting a correct reading for angular rates, for linear accelerations, to compute pitch and roll and heading for those types of environments. We pride ourselves in having a very powerful IMU. It's a tactical grade inertial measurement unit, 1 degree per hour in-run bias stability gyro type of system, low angular walk, and one of the things that I like to kind of highlight the most, scale factor accuracy, I think is significantly not highlighted enough. This is a measurement of how error is going to accumulate with the incorporation of motion. And as we know, drones, they fly and they move and they bank and they move. They're moving pieces of technology. So having a proper inertial system inside to georeference your LiDAR data that has been properly calibrated for the dynamics that it's going to be experiencing is really important. And this IMU is coupled with our inertial navigation system that gives it the ability to provide some type of known lat long of the sensor itself, and then it goes and takes those positions and does a linear transformation and applies those positions to individual LiDAR points that are measured by the LiDAR scanner. And again, we've been doing this for 25 years. So the algorithms that have been developed are quite robust for the various types of environments that they could be used in. The most exciting product for us and for this market right now has been this Echo One LiDAR. This is a collaborative product between Inertial Labs and Teledyne Geospatial, and it combines the best of our technologies with the best laser performance on the market. Our inertial navigation system with that tactical grade IMU is used inside to provide all the measurements used to georeference each individual LiDAR point from the Echo powered by Teledyne there inside. It's a very compact system. This type of performance prior to this product being on the market was very expensive, very, very heavy, and had very tedious workflows. And as we've seen from a number of different players over the coming years, this market has become more cost-effective, lighter, more agile, and much more easy to use for the everyday land surveyor. So this product has come in at a weight of about 1.6 kgs, 8 returns, which gives it superior canopy visibility, penetration below the canopy all the way to the ground, millimeter level range precision, and an operating range of up to, really in practice, it's about 160, 180 meters, but the range of the LiDAR itself can get all the way up to 270 meters. And right there is just a kind of a short little example of what kind of performance you can expect to achieve on a 30-minute flight, which is pretty powerful and saves a lot of time. This is just a good little graphic of a couple of different payloads that ideaForge has supported. The LXT and LAV are shown on here. Additionally, the Echo 1 as well, to show you the one of the big benefits of this product, and that is superior penetration and ground coverage density. It's going to help be able to see all the way to the ground and see everything in between, as well as get a data set gathered in a shorter amount of time, because it's able to fire significantly more points on the ground. So you can fly faster, fly higher, and finish your job that much faster. And below this, we can see kind of just some spec-to-spec comparisons of our inertial navigation system up against some of the other competitor solutions that are being used on the market on payloads. And now I'm going to go ahead and show just some images of some data sets. Echo 1 is here on the left, and then we've got a competitor in the middle and another competitor on the right side. This is really showing you the power of multiple returns. As I said, Echo 1 gets up to 8 returns. This competitor in the middle is 3, and competitor on the right is going to be only 2 returns. And as you can see below the tree line, we see significant more points with Echo 1. And really, depending on the use case, you want to make sure that you have the right product for the use case. But having that visibility, especially for topographic mapping, is very important, especially in complex environments where you might not have the option of waiting until tomorrow to fly. You have to fly today because there's only a handful of hours where it might not be raining. And the alternative is a time of the year where it's 120 degrees Fahrenheit. So making sure that you do have a product that can see everything is important. Right here in this middle picture, I'll show this one in more detail, but this is really just to show, again, the power of multiple returns and what it means for visibility of features within the data set. And then on the bottom, this is a nice little profile view where you can clearly see significantly more structure throughout the middle of the data set, and especially compared to the 2-return solution, perfect coverage on the ground. And on the next slide, I want to highlight more on this middle photo. These are transmission lines. So these are lower voltage cables, which is a good tell for what can be expected in maybe a more difficult environment. The larger the power line, the easier it is to see. But the smaller you go, the more difficult. And on both the 3-return and the 2-return comparisons, you can only see 2 different lines, especially on this bottom row of power lines right here. But on the Echo data set here, you can clearly see that it picks up a 3rd additional line that was completely missed on the other 2. If you look farther through to the other side, you can also see this sagging line that's coming right underneath this line above it that is also completely missed on the other 2 data sets. And that's the kind of visibility that the Echo 1 does offer. And then down here, the railing that's outside this facility is clearly able to be captured with the Echo and is completely missed on the other data sets. So again, this just shows the power of multiple returns to give you a full visibility into what the environment is that you're flying over. And the second topic outside of performance is market adaptation. As we mentioned, COVID was a pain for anybody that did any kind of manufacturing. And now the geopolitical environment requires a new pivot to know who you're purchasing from for security reasons. And what both ideaForge and Inertial Labs have spent an extreme amount of time doing is making sure that we know exactly what is going inside of our systems and done everything required and above and beyond to make sure that we are compliant with all the current regulations to make sure that these types of products can be used on any different type of facility, whether that be commercial or scanning for government or law enforcement types of jobs, or that data security, even though it's all self-contained and not capable of going anywhere, it checks boxes that ultimately make decision makers a lot more comfortable with certain products being on their facility. Outside of just the NDA compliance, REACH, RoHS, WE, and CE compliant as well gives you comfortability and confidence that regardless of where you are internationally, importing and using and gaining the value that this type of product has to offer, you can be comfortable and confident in. And then lastly, as we've seen with the drones, sometimes you don't have the opportunity to choose when you can fly. Sometimes you just need to fly. And having a right platform and a right payload that can handle the different types of environments that you might find yourselves in is cheap insurance, we'll call it that, to make sure that you can get everything that you need done out of your projects. Our IMUs, as I mentioned before, are all military qualified for vibration, EMC, EMI, and a lot of those qualifications have kind of climbed up into the payload space as well for where it applies. Having a quality IMU inside means less calibration maneuvers. So talking about an environment, if you need to take off from a space that is, maybe a kilometer plus away from your actual fly site that you need to capture, having a quality IMU inside means that your trajectory estimation is going to be accurate the entire way there, and that you don't need to make routine pit stops to recalibrate the inertials to align with certain GNSS observables. So having a powerful IMU inside is going to save time and effort and energy in that regard. As Pradeep mentioned, the payload is IP54 rated, and this means that you can comfortably and confidently fly regardless of the conditions, as long as it's not torrential downpour. You're going to be able to when rain starts coming in, you're going to be able to get back to the landing zone without having any kind of interruptions or corruptions or data loss or some type of electrical malfunction because of lack of classification. Extended operating temperatures. This is also really important. There's the United States landscape is very similar to a lot of what India is, as Pradeep already reviewed, and this is certainly true for other portions of the world. The U.S. has its frigid Arctic areas, especially in the winter as you head up north, and then some completely dry desertous areas that for some reason people go on routine runs in at different times of the year to try to not die and prove themselves. But even in those environments, LiDAR systems and drones may have the need to be able to go out and gather data for that particular type of area. And using our systems is going to be able to unlock that ability. And then the last thing is, for these types of challenging environments, this kind of also piggybacks off of the performance, but making sure that the laser system has the ability to see through all of these very challenging, complex environments. You go down to Louisiana, where not only are there huge trees, but there's vines and moss growing through and in absolutely everything. And having those multiple returns to be able to get all the way down to ground floor, to be able to study how the water is moving and where it is going and how much volume can be expected throughout the year. That's a non-negotiable. And routinely in the past, people would pay a very heavy cost with these very expensive systems to be able to get into those types of environments. And now they don't need to. They can be able to find something that's a little bit more cost effective, ergonomic, easy to use, and be able to partner that with a good drone to be able to get the job done. So that's what we have. Guys, thank you so much for your time today and spending time listening and learning. If anybody has any questions, now would be a good time to go ahead and throw those in the chat. We're going to be hanging out for another couple of minutes, and would be more than happy to answer any questions that you guys have.
Thank you, Will. I think we have time for just one question. I see one here. How can I be confident in using this product stack given the current geopolitical situation and regulations surrounding drones?
So it's a really good question. NDA compliance is very detailed in what it requires of suppliers and manufacturers. Both ideaForge and Inertial Labs have spent an obscene amount of time making sure that the entire bill of materials, trickling all the way to providers beyond just aluminum and PCBs, all the way down to the component level inside of our bill of materials, are compliant and following those particular methods of classification and reporting. Pradeep, do you have anything to add on the drone side of things?
No, I think you covered it already. But yeah, I mean, there are additional certifications on the UAV side, which we have applied for. Probably first half of next year, we will announce them as well. There are a couple of organizations that run that certification, Green US, Blue US. So at the right time, we will announce when we have those as well.
It was a
That
good
just
thing to
gives
bring up.
additional confidence to the users.
All right.
Yeah.
Well, thank you both so much. That is all the time that we have today. So I'd like to once again first thank our audience for joining us today, and a special thank you to our speakers for sharing their insights and expertise. We do hope this webinar has been informative and valuable to our audience and their agencies. If you have any additional questions or would like to request more information, please feel free to reach out to Carly Jones. Her contact information is currently being displayed on your screen. As you do exit the presentation, a brief 5-question multiple choice survey will appear. We truly value your feedback, so if you have time, please let us know your thoughts on today's webinar. Once again, a copy of the webinar recording will be emailed to everyone within 24 hours. And if you did qualify for CPE credit, you'll receive your certificate within 3 weeks. All right, with that, I want to thank everyone once again, and I hope everyone enjoys the rest of their day. Bye, everyone.
Thank you, guys. Bye-bye.
Thank you. Bye-bye.